Right, this one here is the second calculus integration type question, and this in fact is an indefinite integral. So if you remember basically in unit 4, the indefinite integral, this time there's no limits on this one, and what we're looking at, this is the basis of it. So we start off with this, and if we integrate that, basically what happens is that you'll get ax n plus 1 divided by n plus 1 plus the constant of integration. That's called the constant of integration, if you remember when you did unit 4. This is a velocity, very important in physics and mechanical engineering. If you've got this sort of situation, this is the equation they would give you in an exam or in an assignment, and what you need to do now is find the displacement. Well, this is a fancy word for distance really, so in fact what you've got to do is integrate this to get the displacement. So what we'll do is, the displacement in physics is given by the letter S, so we've got to integrate it. So I'll just write this down with respect to t, dt. Don't worry about this dt business. This is the main focus here, and we're going to use this idea on the right hand side. Okay, so what we're going to do is integrate it. So we'll just integrate that, add one on and shove it on the bottom, basically. See that? Add one on and shove it on the bottom. So we've now got 3t 3 over 3 minus 8t, that's a t1, so that's a t2 over 2 plus the constant of integration. Yeah, the constant of integration. Yeah, so now what we're looking at now is this s equals that. Can anybody see how we can cancel this down? Well, certainly cancel that, look, that and that will go, and that will actually turn to a 4 there. See that? That will actually turn to a 4. Yeah, so what we're tidying up now is, if we go up here now, see this bit, we've now got t to the power of 3 minus 4t squared plus c. Now if we look at the question here, it does give us actually the constant of integration. See that? The constant of integration is minus 12, and it actually wants us to find the displacement, which we've already said there was s, you see. So in fact we don't have to transpose the equation at all. All we do need to do is substitute this time. The time is here is 6 seconds, so we'd have to put 6 seconds every time you see t. So in fact what we can do now is put the 6 there to the power of 3 minus 4 6 to the power of 2 minus, see it's a minus, see that, minus 12. Yeah, so now we have a situation where 6 6s are 36, 6 6s are 36, and we've got to multiply it again, so that's 36 times 6, yeah, which is 216. Alright, in other words, 6 be 6 be 6, 6 times 6 times 6. Don't do this, don't go 4 6s are 24. You must actually do this bracket first. 6 squared means 6 times 6, so we've got 36, yeah, 36 times 4, which gives us the 144 minus the 12. Don't forget the minus 12. So we're going to have a nice, yeah, we're going to have a nice situation here where we're going to get 72, yeah, minus the 12, and that will give our final answer 60 meters. And the reason why it's meters, remember I said it was distance, displacement. That would conclude that calculation.